Right, so we're going to try to understand why basically it turns, if I get my velocity like that, and I look at my gravitational force, the force is pointing towards the star. Of course, we know the star is attracting it, and this is making it not rotate, orbit the star, so moving in a circle. Now we know that the force is going to be causing the acceleration, and so therefore the acceleration must also be moving towards the center, even though it never actually gets any closer to the center. We're going to try to prove, using our basic understanding of what acceleration is. So acceleration is the change in velocity over the time, which is the final velocity minus the initial velocity divided by time. And we're going to try to show that that would be in the direction of the star, in the center of the circle. So to do that, we need to know how to subtract and add vectors. Now, so let's say I've got this arrow here. I've got this velocity here, and we're just going to draw it. We're going to draw a line that might represent that velocity, and then we're going to draw another velocity like this. And to add those two velocities, what you do, and I won't go into this too much now, but to add vectors, you do them head to tail like that. And so therefore, the resultant velocity will be, to find out the resultant velocity, what you do is you draw a line from the beginning to where you ended up, like that. Very similar to if you add displacement vectors. Man might have walked that way and then walked that way. Where how far is he from the beginning? You obviously draw the red line, and that is how you'd work out the resultant displacement, which is a lot more easy to visualize. But the same method works for all vectors. Now, so what I've done there is I've taken away. Sorry, not taken away. I'm jumping ahead of myself. I'm thinking in my head what I'm going to talk about next. So I've got, let's say, velocity 1 and velocity 2. And I've got velocity 1 plus velocity 2 is what this red line is. So now we're going to think about how would we take it away. Well, so that's how you would add velocity 1 and velocity 2. How would I take the velocity away? Well, basically, let's say I want to do velocity 1, take away velocity 2. Well, I get velocity 1 there. So let's just, that's velocity 1. Label it still. Now, when I take away velocity 2, that's the same as adding negative 2. So I want to flip this around. Let's just say it was roughly there. It's not going to be accurate, but that is actually now negative v2. Okay, so negative v2. Let's label that. And when we subtract it, when we want to do v1 minus v2, now we've got negative. It's the same as adding negative v2. So the resultant is actually going to be from here, from there to there. So that's going to be v1 minus v2. Okay, so that's a very, 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 very quick lesson on how to add and subtract vectors diagrammatically. Okay, there are other ways of adding and subtracting vectors without diagrams. We're not going to go into that because we want to be imagining it diagrammatically, because we have a diagram here and we're going to try to understand it diagrammatically. So now I'm going to delete all that. I have to try to remember it because I think it will distract us from what we're going to look at next. Okay, so we've got this velocity here. This would be our initial velocity. This would be u. And we're going to draw an arrow over the top of it because we're going to want to move that arrow, which this simulation doesn't allow us to do in a moment. And then we're going to, so that's my measure of this initial velocity at the moment. I'm then going to press play, and it's going to move a little bit, and then I'm going to stop. And I'm going to draw another line. And this is its final velocity over that period of time. The arrows are the same length because the size of the velocity, in other words, the speed, has remained the same. But the direction has changed, and so the velocity has changed. And so we say it's accelerated, we're going to try to understand the acceleration is towards the center. Why would that be? First of all, let's try to understand what direction do we expect the acceleration to be. Well, if you imagine the sort of average place would be around about here, and it's going to be pointed towards the center like that. So we're expecting a direction to be roughly that direction. Let's just label V, and we know that the acceleration is v minus u over t. So we're not going to be able to do much with subdividing it by t because we haven't timed it or anything. I know we've got this time over here, but that's not going to really help us at all. We just want to know the size. We just want to know what direction it is, and then obviously if you divide it by t, that's going to change the size of the acceleration, but that won't change the direction of the acceleration. So I've just realised I've written u again, haven't I? Okay, let's just erase that and write v. So we've got v here. Okay, final velocity. Now this is u. We don't want u because we want v minus u, which is the same as v plus negative u. So we're going to, I'm going to use a different color to represent minus. Let's do a blue. So we're going to do blue. Will go from here. Oh, that's not. I want a line. So blue will be. I'm going to draw sort of a parallel line as best as I can. Same length as well. That should be negative u if I've drawn it correctly. So v minus u is the same. I'm going to use this. I'm going to use a white. And we're going to say v minus u is the same as v plus negative u over t. And then I'm going to add the vectors the way that I'm going to, take away the vectors or add the vectors depending on your outlook. So I'm taking away u from v, but you could say that I'm adding negative u to it. It amounts to the same thing. And again, use the head-tail method and look at this. The resultant would be from here to there, and if you take this arrow, this is the one that we expected it. That's pretty spot on. I totally fluked the size of the vector. I really didn't expect it to be spot on, but that is a complete coincidence. I just fluked that. But the point is the direction is exactly right because that's what happens when you subtract vectors. And that's why the acceleration is always towards the center. You can prove that with visual representation of vectors. Okay? And I'm not going to stop if I click that. Let's try up here. Okay, stop over here then.